Hey guys, my name is Arun Tyagi and we are discussing about low-level design patterns here. So let's talk about another structural pattern. So far we discussed adapter pattern and bridge pattern, and this code is available on Git. I'll add the link in the description box. Let's talk about the composite pattern now. This is actually one of very useful and a kind of a complicated pattern to implement. Let's first just state what this patterns, what's the definition, official definition of this pattern. Composite pattern describes a group of objects that are treated as same way as a single instance of the same type of object. The intent of composite pattern is to compose object into tree structure to represent part, whole, hierarchies. Now, what does that mean? So imagine, you have a type of object where, for example, you have this main object of any type. It can be like employee, man, or some product, and that is having some kind of, child list. So like this child, to child, ultimately basically this your main object is having a list of some type of object, right? And this can be any number of time. To handle something like this, the only thing is you can actually use iterative, we call an iterator. So like we use IEnumerable, iterator, right? In Java we use these very frequently. So this is an iterator. We normally use iterator pattern to handle something like this. What is the use of that pattern? Is that you want to provide a way to the clients of this object to run a loop over this entire list, but at the same time you don't want to expose whether you save it into an array, you save it into a linked list, or you saved it into array list, or on anything. Because if you will expose that, then client is bound to read it like that. Means then client is need to know how to read a list, how to read an array list, and anything, right? They have to implement. But if you will simply provide your functions to iterate, if you will provide your iterator, then client can simply use your iterator to fetch these one after another. So something like this can be handled via iterator pattern. But if you have list, like you have this main object, and now this main object is having a child like above, then another child, then another child. What if this child itself is having, another, basically a list of childs, right? Think of something like this. So this is having child, again this is having another. So this particular child is having list of same type, right? And what if someone, one of it is also having a list of childs again? So if you have this, so if you see, this is nothing but a tree structure. So main object is having a list, then one of the item is again having a list, then one of the item is again having a list, till, and ultimately you will have some leaf nodes. So from main to leaf, this is becoming a tree. So if you have to provide, your clients, the clients of this object, a way to iterate through these, iterate means they maybe need to add something here to all the items. So ultimately they have to iterate through that entire structure. What should we do, right? So in those places we need to use a composite pattern. So this is a pattern people have defined that do something like this to basically provide a way to your client to run through all your objects, in this hierarchy. Okay, so to achieve this, let's discuss an implementation. In our team, we see the hierarchy. We have manager. Under manager, you again have some managers, and maybe directly some developers, and under those managers also you will have some developer and manager. So this is a tree structure. Let's try to implement that, and let's see how clients can access it. Okay, there can be different ways, so I just used two ways, right, to achieve something like this. Let's suppose you are having an employee interface. Employee, ultimately there will be a concrete class also. If you are having this, and for simplicity I'm just taking one functionality into it, update task, that if you want to update task of this employee, so this is the function you have to access, and you will pass the task here. Okay, let's first see this implementation, which is like using leaf and tree nodes directly. What we can do. So let's just define clear objects. So you are having iEmployee, one is like you are having manager type, one is developer type, so you just define two different types, and third is actually the list I was talking about. Let's leave it this one for now. So manager and developer is very simple, right? Manager is also having some update tasks, different functionality, for example, and employee, basically developer is having different implementation of this update task, right? Maybe for manager there are some extra things you have to do when you are updating the task, but for developer you are having different implementation. So both these concrete classes are defining their own functionalities. Now let's talk about the team directory. Though this, if you see whether your team directory is an employee, no it's not. So you are kind of breaking the OOP rule to achieve this pattern, but this is just a matter of name. You can actually define it like I list of iEmployee here, iEnumerable of iEmployee, but let's leave it for now. Like I said earlier, focus on what we are trying to learn here, what is the intent of this, and ultimately when you will do, you'll be able to join all the dots. So when I'm having a team directory, you can call it a team. So what this will have a list of iEmployee. List of iEmployee means you are having managers, you are having developers inside it. Then maybe here also you are having update tasks, right? And this one can be used to run tasks, to update tasks of all the employees, right? So how can you achieve something like that? That I will run a loop on it, that for all employee in my list, what I will do is, for each employee in, for each, you can say my temporary employee, I am again having my employee here dot. Okay, so oopsie. Right, so basically what we are doing here is that so you are having update task here itself, and then you are having list of all the employees. To add an employee, you basically just simply define add an employee into this. Now how a client will use this, right, and how client will update task of any employee or tasks of all the employees. Let's just see this example. What client is doing, they created two developers, they added those developer directly into the team directory. Now they created again two developers, they added these two developers under your manager, right? My manager is of type this rather than basically this, because all of them are of type iEmployee. So I added two manager, and under manager I actually added this developer and this developer, and ultimately in my team I added basically my this engineering unit and this managerial unit, and manager are actually having developers under them. So this is how this is a way client is basically trying to create that entire tree structure. Now when you will call update task, you can actually iterate through the entire tree in this in this method, and you can call their respective update employee update task functions. How we can do that is, for each employee in my employees, for each employee in my employees, what I am doing here is basically, first of all, I will do employee dot update task. So this is for that particular object I'm updating. Now this is again might be having the child, right? So what I will do is, if my employees is further having subordinates or employees, which is this one, right, then for all of them, and this is throwing error because I haven't defined that in the constructor yet, sorry, in the interface yet. I'll do it, right? And just do the same thing, update, just call update task. That's it. E dot update task. So the same thing will happen. It will again and again, it will call the function in depth till your leaf node is there. It will update task for all of them. Okay, so let me just simplify it by taking another example here. This one looks like a little bit of little bit complicated. So let me just try to simplify it with another example. For example, let's suppose you are having a class of you can call it your main object, and this is of your component type. Right, so I haven't defined this. Let's suppose this is having one of the interface component type. We'll give the definition here. Now this guy is having list of component type, and these are my childs. Children, which is a list. Now this object, because this main object also is of this type only, right? So this is ultimately having some properties called name, string, my, OTHER, other properties, other props, dot. Then how to write the function which we were talking about earlier, that how to iterate through all, and how to hit some functionality of all the nodes in that tree. So let's suppose I'm having action on all.